Go and do it for me. Now watch me whip. Kill it. Now watch me nay. Okay. Now watch me.
All right, we're coming live. Review session, pre-cal 4.5 to 4.8. Hey, hopefully you're doing good today. Little music in the background, never hurt anybody. And we'll slowly bring it down. There you go. All right. Right on. Hey, hope you're having a great night tonight. Hopefully with the pre-cal review. Hopefully you're on the YouTube link. If you have any questions, please feel free to ask me at any time. Remember the communication. Communication's a little bit different. If you have a question, you can call me, or, well, probably not call me since I'm on the air, but if you want to text me at 770-757-2240. You got a question, I've got an answer. We're going to get this party started. This is strictly pre-cal, no Algebra 3, so for the next 45 minutes, my questions are your questions, and we'll get those questions answered. Remember the answer sheet posted right below the link that you found online under Chapter 4 in Haiku. Oh, man, I'm excited. I mean, seriously. I mean, how excited can you be? We got a pre-cal review here. Again, shoot your questions my way. Make sure when you shoot the question my way, you end up giving me your name there. That way that I can have that. Most of you already have, but just to make sure I have that, have your number, make sure that you put your name and the number that you're trying to ask about. All right. Hey, again, hope you're really having a good night. We're going to get it rolling here because we know we're going to end at about 4:15. That way I can post this online and we'd be good to go. If for some reason we need to end a little earlier, we can, but we'll get it and go from there. One thing that I do want to make sure that I let you know about within our section is this, that the review is pretty good. It's going to be pretty nice comparing to the test. So as you prepare for the review, you'll be preparing for the test as well. And so just a couple things there. That's again, just some advice. The reviews pretty nicely. The first one, maybe not so much. This next one is pretty doggone close to what the review will be like. Also study your quiz. Quizzes will be good as well. And let's get this show on the road. All right. We got a question. And all the way from South Carolina. Oh, no, not really. Actually, it's actually Cassie. Cassie, what's up? Cassie's coming in live with us. She has the first question. First question is this. Hey, Coach, could you please make sure, I'm going to make sure here that I'm talking. We're good to go. All right, making sure everything's good there. Yeah, that's a good question, Cassie. Let's try to do this. On the test tomorrow and or Thursday, what you're going to do is you're going to get two things. You're going to get our tan inverse, sine inverse, cosine inverse. All right, that is associated within our four quadrants. All right, remember when we talk about something that's positive, we think of all students take calculus, right? But when we refer to inverses within our range, we have certain inverse ranges that we are limited to. So we know that sine, cosine, tangent is all within the first quadrant, okay? So we can have all of those three values within that first quadrant. Now, within the second quadrant, we're limited to only having cosine inverse, right? Third quadrant, we have nothing. And fourth quadrant, we have sine inverse and tangent inverse. So it's important when you approach this problem to understand. I think I actually wrote a couple of them at the bottom of the page that are going to be important to note. I think it's at the very last page on the bottom. You could tell that I wrote them in. There's three of them. Those are ones that I really focus in on, make sure that you understand that going forward. So again, this is what I will give to you, making sure, again, it must be in that range if we're talking about something that is an inverse there, all right? So Cassie asked if we could do 9b. All right, so let's do this. Let's go to 9b. I'm going to pull up that answer sheet here, kind of put it alongside. That's a good one. Cassie, that's a really good one. All right, remember with this one, we have arc cosine of cosine of 2 pi over 3. Now, I will also give you the unit circle, so that's something else that you kind of put in on that, or I probably will end up posting the unit circle on the front of the room so everyone can see it, because you only need it for certain problems. But with this specific problem, we're trying to solve for what cosine of 2 pi over 3 is. So my first thing is when I work inside out, I can't cancel this because a regular cosine is on the inside. So when I look at cosine of 2 pi over 3, I'll go to that location and notice that cosine of 2 pi over 3 would be negative 1/2. So since that's negative 1/2, I've already done what was on the inside, and now what I'm going to do is I'm going to work out. So now I'm going to do the outside and find what the arc cosine of negative 1/2 is. Now remember, arc cosine is the gangsta name. Okay, that's the gangsta, G-A-N-S-T-A, gangsta name of cosine inverse. So arc cosine and cosine inverse are the same thing. So if you looked at cosine inverse of negative 1/2, that value would actually be, well, we have to look and see where it is in my range. So I know cosine inverse has to be in either the first or second quadrant. So my next question is where's cosine inverse going to be negative? Well, there's really only one value where it will be negative. We only know that it'll be negative on the second quadrant, whereas the cosine inverse in the first quadrant would be positive. So we know it's in the second quadrant, and we look and see, well, at what point is x negative 1/2? Well, there's only one location in that second quadrant. The answer would be 2 pi over 3, okay? Note, cosine inverse has a range from 0 to pi, whereas tan inverse and sine have one from pi over 2 to negative pi over 2. Be careful if you get a negative sine inverse or negative tan inverse. We always want to go backwards, right? We always are going to do like negative pi over 6 rather than saying 11 pi over 6 if we ended up getting that value. Just something important to note. I think there's one on a previous problem on the review. I forget which number, but I think we did it in class. But that's one just important to note there for future reference, all right? All right, awesome. We're going to change up the color a little bit, change it up. All right, let's do this now. Let's go to the next one. My next question, all the way from Louisiana, here. So we have some people out here who are making fun of me, maybe of my dance moves or something of that nature. I appreciate you for making fun of me. Some people out there saying right now, live saying, hey, coach, you enjoy talking to yourself. Teresa just did. Well, Teresa, thank you so much. A shout out to you. I do enjoy talking to myself. It's weird. I feel like I'm on Dora the Explorer, but hey, you gotta be a little crazy to teach, and so I'm a little crazy there. Hey, also shout out to Mayonnaise and JT. JT all the way from LA. If you want to visit LA, you could just talk to JT there, and he'll help you out with that. All right. All right. Let's do the bearing problem. All right. Let's do a bearing problem. Let's go to the one. I don't think it has actually a number, but I think it's on the first page. I think it's towards the bottom. So we'll start it from the bottom. Now we're here. All right, here we go. Let's go. Airplanes, 500 miles per hour. It goes for 1.5 hours. Okay, that's important to know. It also says that it goes northeast, right? Northeast, and I think it says, let me make sure, north 47 degrees east. All right, so it gives this information. This is kind of the important things that we need to know. Sometimes it helps if I just write out the 3 important things, and then I can always go back if I feel like I have some loose ends. So the question is this: how many miles north and how many miles east did this plane travel? Well, it's important to note that the plane will always start within my origin, all right? Unless it has more parts to it, it will always start at my origin. So what's going to happen is this plane is going to travel within the northeast direction. Now remember, when we go north and east, that bearing of 47 degrees will end up going towards the right-hand side. So it's like we're going to the right-hand side, north 47 degrees east, all right? A lot of people in class put 47 down here. Now make sure you don't do that. That's not 47. It always will connect within my north, the end that is up there, all right? So now, if that's 47 degrees, what would this be down here? Well, this would be 43 degrees. While I'm also saying this, also note there is another way where you could connect it up here, but just to keep things consistent, I'm going to use what remember my reference angle, right? I'm going to use my reference angle here. and be able to use that to then solve. So this is 43 degrees and this is 47. I know that 500 miles per hour is the speed at which the plane is traveling. But if it travels 1.5 hours at 500 miles per hour, it will have 500 miles for the first hour and 250 for the next half hour. So when I add that together, I get 750 miles that it's traveled towards this destination. So again, I'm trying to figure out now, what is X and what is Y? How many miles east did it travel and north did it travel? Well, now this is where I kind of can use my trigonometric, if I could talk, good night, trigonometric expressions, there you go. And I can use sine and cosine to now isolate or to get Y and X by itself. So remember that if I have the opposite of 43 degrees and the adjacent, I can use that as long as I have my hypotenuse with it. So I could say this, sine of 43 equals opposite over hypotenuse. So if I plugged it in, I get sine of 43 equals Y over 750. All right, so get 750 by itself by multiplying by both sides here. And that's how I isolate Y, or the amount of miles that I traveled north. Now, when I plug that in, we're going to plug and chug, get on the train, plug and chug, plug and chugging, plug and chugging. All right, we get 511.5 miles equals Y. So that's the amount that I traveled north, because we think hence Y, up and down. The next thing we could do is, if I know what the adjacent side is, or we're trying to find the adjacent, we know the hypotenuse, we could do the same thing with cosine. Then we get cosine of 43 equals adjacent over hypotenuse. Multiply by 750, I'll get 750 cosine of 43 equals X. When I do that, we'll do the same thing, 750 cosine of 43. That will get 548.5, okay? So X equals 548.5. All right, and that's the amount of miles that it traveled east. So there we go. That's how we solve for a bearing problem where we go to the east side. I'm actually I'm going to keep going to the right, east side, and the north side, okay? East and north. All right. Good question, JT. Good question there. All right, let's see if we've got another one. It's boring without y'all here, because I just talk to myself. No one laughs at my jokes. Literally, I'm talking, and my wife just rolls her eyes when she hears all my jokes and stuff. Y'all at least somewhat pity laugh, you know. All right, mayonnaise. Mayonnaise says this: how do you know when the answer is in pi or it is a number? For example, when do we want it to be in pi over 6 or radical 3 over 2, like numbers 8 and 9? You know, that is a great question. First thing to know is that if I ever have the cosine of cosine inverse of, let's say, square root of 2 over 2, one thing to note is that when I have the cosine inverse on the inside of cosine, I can actually cancel these out to just get square root of 2 over 2. I could work on the inside and then go out. However, I do not actually have to do that. That's not a requirement, okay? I actually do not have to do that. All I have to do here is, with the inverses on the inside, cancel, leaving me with square root of 2 over 2. Another important thing to kind of note here is anytime that I have the cosine inverse of something, say square root of 2 over 2, or if I have the regular cosine of, let's say, pi over 6, all right, this is kind of what you were saying. Anytime I have the inverse of something, I want an angle in terms of radians, right? All right, that's what I'm looking for. So when I give an inverse just means that I'm finding the opposite of what a cosine would be. Remember, in cosine of pi over 6, you all know that I'm going to go to pi over 6 and look to see where the x is and then get out a value. So when you go to pi over 6, the x value would be square root of 3 over 2. However, when we look at inverse, anytime I find an inverse, we're looking for an angle, right? A lot of times in word problems, we're looking for the angle of elevation. So when I'm looking for that angle using the inverse, when we use the inverse, we're always looking for the angle here. So cosine inverse of square root of 2 over 2, we know it's got to be in the first or fourth quadrant, right? Up here, up here. We know it's positive at first quadrant, so we know it's up there. And so where's it square root of 2 over 2? We know it's at 45 degrees, so we'll put it at pi over 4. Notice, angle is associated with inverse. A regular cosine is associated with an actual value, all right? Awesome. And oh, by the way, while I'm talking, if for some reason you don't understand that still and you still put something out there, hey, feel free, pause, still ask me a question, say, hey, coach, could you go back to that? And we'll do that and go from there, okay? Mayonnaise, I hope that helped you. All right. Yes. Next, make sure here, trying to look. I have a very good question. Got a good question from Teresa. Teresa said this, could you go over number 13? I'd be glad to. I'll do 1 on 13. And then she said, could you do the bottom 3 below? I'd love to. Okay, let's look at that. Let's actually do this. Let me go backwards. Well, actually, let me go forwards. Sorry. If y'all are sick, I apologize. I'm totally sorry. Just kind of get out of control a little bit. All right. So let's do number 3. I also saw a number 6 on there. I'll do in just a second. But let's do number 13 up there first. Before I do that, though, let me do the ones down here. Remember our ranges, right? Remember our ranges. If you don't know them, they're on the first page at the beginning of the podcast. If you didn't watch the beginning of the podcast and you skipped, shame on you. Shame on you. Seriously. Literally, what I'm going to do is I'm going to haunt you and your children's children someday. I promise. I will haunt your goldfish someday. All right? No, I really won't. Please don't turn me in. I was just joking. All right. While I'm writing those down, here are the 3. Now, let's look at sine inverse of square root of 3 over 2. Now, it's important to note with square root of 3 over 2 that sine inverse has 2 different spots that we could have within our range. The two spots are the first and the fourth quadrant. I mean the first and the fourth. Now to determine which one it is, I know that sine is negative down in the fourth, and we know that sine is positive up in the first. So because it's positive square root of 3 over 2, I know something's going off in my head saying, oh, please do it in the first. And you'd be exactly right. My head would be exactly right there. So do we be actually going to the first quadrant and determining what angle would be associated when y would be related to square root of 3 over 2, okay? Just like Mayonnaise had asked, I know that I have an inverse, therefore I know I want my answer in degrees, some sort of degree or angle. Well, and I said degrees, I meant in an angle with radians, that's what I meant, okay? We wanted that angle in radians. So I look and see where's the y associated with square root of 3 over 2. Well, I can look up above and notice that, okay, at the 30 degree at pi over 6, I'll notice at that spot, it is square root of 3 over 2 comma 1/2, so that's not good. No bueno. Then go to the second one, 45 degrees. We know that that's not it. And then I look at the 60 degree. At pi over 3, I notice that the y is associated with square root of 3 over 2. Therefore, my answer will end up being, I almost wrote that down. My answer will end up being an angle, which would be pi over 3, is associated with square root of 3 over 2 within my range. Now let's look at another one. This time, let's go to this one, and then if you needed some help on this one, Teresa, just let me know. Hey, could you come back to the second one? Let's look at this one. This time, I'm going to do it in purple so you can kind of see. Again, we have the same range for tan inverse. The problem is that this 0 is neither positive or negative. However, we do know that it's y over x. So one way to kind of determine, where this thing is or at what angle is this going to be y over x, you could kind of know that since it's neither positive or negative, it's probably going to be on my quadrant, right? So I'm on either the y or x axis. So if I started over here, what I could do is start on the right side. We'll go to the right. And when we do that, we'll do y over x, which would be 0 over 1. Well, I think I found it, because if I do 0 over 1, that equals 0. And at that spot, this is a little bit tricky, but the value is 0, which is correct. However, the answer will actually be 0 as well, except it's not 0 as a value, it's 0 as our angle in terms of radians. So what I would do is my tan inverse of 0 would actually be at the spot or at the radian measurement of 0 radians. And that's how we would figure that out for number 13, okay? All right. Yes, I will hurt your goldfish. Just kind of throwing that out there. Lone wolf. Lone wolf, I will hurt your goldfish. So hide your kids, hide your wife, all right? JT, you have a great question. And I'll get to that number 13 in a second, Teresa. When is our calculator in radians or degrees? Well, as far as this test is concerned, there's a calculator and non-calculator section. For the most part, I'm going to say every time on this test, if you're using your calculator and you're able to use your calculator, you need to make sure that you convert it or that you keep it in degrees. Because there's never a portion or a time where you're going to find, like in a word problem, you won't ever find what's the sine of pi over 3, right? You would say, what's the sine of 60 degrees? And so just so you're aware of that, that's not something I'm going to be requiring you to do. So just make sure that it's in degrees. If it needs to be in radians, the key is if I'm trying to get out radians, then you'll keep it in radians. If I'm trying to get out degrees or I'm putting in degrees, you'll keep it in terms of that, okay? And JT, if you're struggling on that tomorrow morning, we could kind of look at that a little bit more if that's a struggle for you, all right? Number 13, lucky number 13, we're going to do that one. All right, hopefully all my YouTube followers. Hey, a little bit of a shout out real quick. I've got some followers over there in England, about a class of about 60 over there. Hey, Professor Johnson, coming to you live. Hopefully you do well on your pre-cal test tomorrow. Also, some people coming from India. It's good to see you out there, my YouTube followers. And there'll be shirts coming out shortly that says Coach Jay's podcast. Will have a cool little symbol there. So people from India, you're there. Shout out. And then also Sweden, all the way from Sweden and even some in Canada. All right, little shout out there. And then also GAC as well. GAC has some people in as well. All right, so a little shout out there. Number 13, let's look at the first one. Tan of arc sine of 3/7. All right, tan of arc sine of 3/7. Now, an important thing to note on a problem like this is that we always want to work inside out. Now, if I had this, where this wasn't a tangent, but let's say it was a sine, okay? Let's say this wasn't there, but it was a sine. We could actually cancel out because the sine inverse is on the inside. But because they're not the same, we actually cannot. So what we're going to do is we're going to work inside, then work our way out, okay? So because of that, we're trying to find the angle where arc sine is 3/7. So we're going to draw our triangle here. Okay, draw a triangle. There's a 90 degree. We'll put theta here. That's our, I always call it our focus point right there. That's our focus point. And since sine is opposite over hypotenuse, we can look opposite of that theta to get 3, and our hypotenuse can just simply be that 7 there, okay? So now in order to find tangent, we must determine what the adjacent side is. So what we're going to do is we're going to say 7 squared equals 3 squared plus x squared. We'll put that in as x right there. So we simplify to get 49 equals 9 plus x squared, subtract 9, square root it. I got the square root of 40 equals x. Now, a little bit of a struggle is this. With the square root of 40, we can actually simplify that, all right? Yeah, that's a great question. And quick question before I keep going. Remember, this right here, if arc sine or arc of anything is on the inside, it could be arc tangent of 3/7. And let's say tangent was on the outside. If they're the same, you could cancel, leaving us with 3/7, all right? So again, that's important. This would be 3/7 in this case, but since they're not the same, you cannot cancel, okay? It could be arc your mama right here. It doesn't matter what it is. As long as it's in the inside and the same thing's on the outside, we are G to G, And for those of you who don't understand text messaging, that means good to go. All right, good to go. All right. So now with square root of 40, we can take out two things, a 2 and a 20. And in 20, I could take out a 2 and a 10. 10, I could take out a 2 and a 10, and, or I'm sorry, 2 and a 5, and we are done. Now, as I look at these values here of the factors that are from 40, I notice that I can take out a 2 because it's in common. So I'll take out 1, 2, and leave out the 2 and the 5 that's left over to have a square root of 10. So instead of x here, we can actually input the 2 square root of 10 in for x. So when I come back to tangent, I know it's opposite over adjacent using the same angle that I started from. So I go to opposite over here, over adjacent, 2 square roots of 10 to get 3 over 2 root 10 right there. Multiply top and bottom by root 10 to get my answer of 3 root 10 over 2 times square root of 10 times square root of 10 is 10. 2 times 10 would be 20. So 3 square roots of 10 over 20 would end up being my answer for tangent there, okay? Again, the big thing, when I say what is my angle here, I'm looking for what my focus point is. Where's my angle? Then I use that angle to find what tangent would then become, all right? Use that one to find what tangent would become there. All right, next one. Going straight down the list in order. Someone, Alexis, has a question, okay? She says, can we do number 6? Alexis, I'd love to do number 6. That would be great. Number 6 is very similar to the one we just did, which would make sense. We could do that one. All right. In fact, what I'm going to do, I'm going to actually do this. Alexis, I'm going to show it up here. Let's see if we can see here. Sorry. Used to play the trumpet. Not really, but I was part of the handbell choir, though. Part of the handbell choir. All right. Let's see if this works. Ah, there we go. Right here. We're actually live right here. This is good. Yeah. So if hopefully you could see number 6 here. Number 6. This is the problem that I did. I wanted to show this to you, though, Alexis. Look at arctan of x plus 3. This is very similar to the one I just did. The only difference is now it's not 3 over 7. The opposite side would be now x plus 3 with the adjacent side being 1 because it's tangent, right? These aren't the same, so I can't cancel. So I have x plus 3 over 1. So I do the Pythagorean theorem. Now notice when I do the Pythagorean theorem, I get x plus 3 squared plus 1 squared equals c squared. I then square root. One big thing that people don't note is x plus 3 squared. That's an important thing. X plus 3 squared. I'd have to actually distribute the x plus 3 times the x plus 3. So when I distribute that, I get x squared plus 6x plus 9. Then I add that 1 to get that plus 10. So right there, that's my hypotenuse when I square root c, and I put it on this side. All right? Hopefully this is helping. Now, once I do that, I can then find the sine of it by doing the opposite over hypotenuse. Because this is such a big square root in the bottom, I can leave that as is to have x plus 3 over the square root of x squared plus 6x plus 10. And I can leave that as the answer for number 6. All right? Again, hopefully that was helpful for you. If you need me to really go through it more, I can either do it tomorrow morning, or if you have more of a question on it, you can even ask me. In the session. We can go over that together as well. But since I did one similar, I figured maybe we could get by with just showing that instead of me having to go through it there. All right. Perfecto mundo. All right. Let's see what other questions we have out there. Okay. All right. Could we do one where the inverse cosine is on the outside and the regular cosine is on the inside? I'd love to do that one. That would be a good one. In fact, I think there is one on the review, but I'm going to give a different one just so that you have something different to go off of when you study. All right. How about cosine inverse of cosine of, I don't know. Let's do this. Let's go negative pi over 3. That's a good one, Coach. Thank you very much. Again, I feel like Dora the Explorer. Backpack, backpack. There's swiper. Don't swipe them. All right, here we go. Inside, we work inside out. So cosine of negative pi over 3 is our starting point. cosine of negative pi over 3. So if I start on the inside of cosine of negative pi over 3, I first have to note that we'll ultimately get to the inverse, but not yet. We know negative pi over 3 would be the angle that goes in the negative direction, or negative 60 degrees downward. Or you could also say that this is the same as 5 pi over 3. Okay, this is the same location as 5 pi over 3. So as we look at that, negative pi over 3 is going in this negative direction at 5 pi over 3. The value we'll find for cosine will end up being, at 5 pi over 3, will end up being 1/2. Okay, because again, it'll be a positive. I think the point there is 1/2 comma square, negative square root of 3 over 2 or something like that. Okay, but 1/2 would be there. So we're done with that one. Now we're going to have the second part, which we'll do in green, which is the cosine inverse of 1/2. So now I look at the cosine inverse. I know it's got to be in the first or second quadrant because of my range, my limited range. And so because of the limited range, where's cosine going to be? Cosine inverse going to be positive 1/2. Well, I know it's got to be positive in the first quadrant. So in that first quadrant, where is cosine going to be associated to 1/2, or where's the x going to be 1/2? Well, there's only one place. That answer would be pi over 3. So the actual value wherein cosine inverse is 1/2 would be the location of pi over 3. And that's how you would do one that would be something of that nature, all right? Yeah, remember too, mayonnaise, if arc is on the inside, cancel the inside. So like, let's say it was cosine inverse of cosine of square root of 2 over 2, right? I'm sorry, this should be here. Apologize. If it was cosine of cosine inverse, inverse is on the inside, we could cancel, getting me square root of 2 over 2. All right? Great question. Yeah, remember too that when we find our asymptotes, I love that word. It's a great word. Give me a good word there. Can't believe I'm saying this on YouTube. I apologize. I don't mean it that way, but you get what I'm saying. All right. So if I did tangent, right? Tangent has asymptotes that are set equal to negative pi over 2 and pi over 2. We're talking the bx minus c or plus c or whatever it may be. Cotangent is related to 0 and pi, all right? 0 and pi. So bx minus c would be associated with 0 and pi. Same thing. So if it was cotangent of 2x minus pi, okay? Again, I'll set 2x minus pi equal to 0 and 2x minus pi equal to pi. And I'd add pi, divide by 2, all of that jazz, and we'd be good to go, okay? But that's how we would do it. Set equal to 0, pi, tangent, we'd set for pi over 2, negative pi over 2, all right? All righty, that was a great question. Cassie, that was a good question there. Lone wolf, all the way lone wolf, but you're not a lone wolf because you have sea bass. You are not a lone wolf anymore because now no longer are you one wolf, but now multiple wolves in a pack full of wolves. All right, hopefully you like that. I guess we can go from there. All right, so, oh man, I apologize. I did not know. Yeah, some people are thinking that I'm crazy. Hey, this is what happens when you are by yourself in a room with no students. This is why I could never do long distance learning. I've got to have you all in the classroom. You've got to laugh at my jokes because they get cornier and cornier the more that we the longer we go. So again, I apologize for what I'm saying. All right. Let's get it. Oh, all right. Let's go to the next one. Other than the crazy thing, I think lone wolf. Let me see lone wolf here. Lone wolf, all the way from Sweden. Say, could you go over number 1, por favor? Por favor. All right. So since he said por favor, we'll do it. If he didn't say that, we may not have been able to do that. But now that he did, we're good. All right. So let me see if I can memorize this and put it on there. All right. 2 sine of 4x, and I think I messed up already. Let me see. No, we did. We're good. 4x minus pi over 3 plus 5. Okay? So we have y equals that, all right? All right, so yeah, you should get bonus for coming in and listening to my jokes. Yeah, I hear you on that. I'm sorry. Maybe not this time. I do it randomly. So sometimes I'll do the bonus, sometimes I won't. Maybe next time. Maybe next time we can do the bonus. There will be a bonus on there. I will tell you that the bonus that will be on there will be, I'll give you 2 word problems and you can mark whatever one you want as a bonus. One of them will be the bearing problem, and the other one, excuse me, I don't remember what the other one is, to be honest. But those are the 2 that you can pick there, okay? With this number 1, I know it gives like a weird description of what I'm asking for. Really all I'm looking for are 4 different things. Amplitude, period, phase shift, and vertical shift, okay? So I've got these 4 things that we're looking for. Now I know we have center line. Really center line is just the, it's kind of like the gangsta name for vertical shift, okay? I don't know why I like gangsta name. I don't know what I'm doing. All right, I'm sorry. I apologize. All right, so amplitude. First thing we want to do is find what the amplitude is. Remember the amplitude, we always have A, B goes with the X, C is by itself, and then that +5, if it's hanging out there all by myself, we know we're going to end up having that as a vertical shift, okay? So +5 will end up being my vertical shift. My amplitude will be +2 because that's what my A is there, okay? Now, the next part we have to do is our period and our phase shift. Now, with period, it's always 2 pi over B, right? 2 pi over B. Since B is 4, we know that it'll end up being 2 pi over 4. 2 pi over 4. Now, if that was reduced, my answer would then be pi over 2. So my period would then be a distance of pi over 2. Now, remember, if I was graphing that, period is the distance I travel, right? That means that in pi over 2, I've got to go up, down, and back up again in the distance of pi over 2 or whatever my period was there. Remember, phase shift is always my starting point, right? It's my starting line, all right? Starting line. Phase shift is always C over B. So since we know C is pi over 3 and B is 4, and we'll put over 1 just so that it's not just hanging by itself. It's no longer a lone wolf anymore. It no longer is no longer a lone wolf, but now it has 2 in its pack. So no longer is it a lone wolf, but multiple wolves. If we flip that to the top, we then multiply by now 1 over 4. In doing that, we then multiply across. Don't cross multiply, right? That's when it's equal. But when we multiply across to get pi over 12. Is it positive or negative, coach? Well, remember, it's negative up here. Therefore, we have the opposite sign. So we'll have positive pi over 12, or you could say it goes to the right. Remember that the starting point's phase shift, period, the distance I travel, vertical shift is up and down. Also, remember the tangent and cotangent. You do not have to find all of this. You only have to find the asymptotes and the amplitude. That's there. All right? All righty. Very nice. All right, let's keep it going. Let's go to, that's fine. We'll do some orange or yellow. We'll do yellow action. Y'all, I'm crazy tonight. I'm sorry. I apologize. Apologize there. All right. That is it for my text messages right now. I actually have none here. Actually, yeah, I have none there. Any questions? Any more questions out there? Hopefully, you could text it in to the hotline over here. If you're from Sweden, make sure you put 1-800 before that number, and then you could continue there. I'm trying to see. You know what I might do? Let me give some. While people are texting in last few questions or so, let's do this. Let's go to let's do this right here. All right, let's do this. Hey, on this again, numbers 1. I wanted to go towards the bottom. Start it from the bottom. We'll go to number 15. 15 is actually wrong. You'll notice I thought it was sine. I actually was incorrect in that. It's actually tangent. So because it's tangent, just make sure, cross that one off. I did not do that one right. Again, if you need to know how to do a tangent one, like number 12 would be a good one. I think that's the only one that I put on there. Go on your quiz. You can look at your quiz review. But I don't know what I was thinking. I was messing up. I messed up there. But with tangent, remember you'd set 3x minus pi over 3 equal to pi over 2. And then the second one, you set it equal to negative pi over 2. So just be careful on that. You also noticed, I think maybe I didn't put it on there. I thought I circled some stuff, but maybe I didn't. There were some areas like up in here. Y'all gonna make me lose. I'm sorry. 8 and 9, numbers 8 and 9, those ones I would focus in on. Number 13 is a good one. Those ones on the bottom here, those 3 that I put on the bottom that we did, that's a good one too. Knowing how to graph, a lot of people did pretty good on that. But go to your quiz, make sure you understand that, because I know there's like 3 or 4 on there where you have to actually graph it. And again, you want to be efficient on those. You want to move through those fairly quickly when moving through those on that one, all right? On the test, I wasn't planning on giving the formulas for like period, phase shift, and all that. I don't think there's a need for that, to be honest. If you know that phase shift is C over B and periods 2 pi over B, really that's the only thing you need. So unless you're like begging me like, coach, I have to have it, I think we can do without it. I think the big thing is just remembering that tangent, we find amplitude and asymptotes, we set it equal to pi over 2 and negative pi over 2. Cotangent, we set it equal to 0 and pi. So if we figure that out, I think we'll be good to go, all right? Seabass just asked, can you give me the test right now? I would love to give you the test right now. However, if I did, I would have to give you half credit since you saw it earlier. So because of that, however, I would love to give you the test. I'm unfortunately unable to do so. But thank you for asking. All right. I think that's it. Man, what a great study session tonight, y'all. What a great study session. Coming to you live from Coach Jay's home. Man, I can't even think of anything else. I mean, how do you end these things? I mean, I need to figure that out, how to end these podcasts, because it's kind of gets weird and awkward. I get weird and awkward here. I just don't know what I would do here. I guess we just sign off here. I guess this is it. I mean, I don't know. Yeah, this is Coach Jay, pre-cal review 4.5 to 4.8. Hey, check this out again. If you hear of people who need this link, tell them on chapter 4 on the very top. I'm going to put that or post that up on the top so that they can see it, but it probably won't be up till pushing 10 tonight just because it takes a little bit while to upload on YouTube. Hey, this is Coach Johnson signing out. Hopefully have a great night. We'll see y'all tomorrow morning if you need some more help. Hey, have a great day. Dominate the test. I know y'all will do great. Care about you. Love y'all. Bye. Bye. Oh, I'm still going.